Hi students, so today we are going to put together everything we've learned about congruent and similar figures and really get to what this unit is all about, which is transformations. So on this page, I'm just going to kind of go over what the different transformations are in some of the vocab. So vocab at the top. Pre-image is one way to refer to the original figure. So whatever you started with, whatever the thing is you're comparing the other one with, the pre-image is the original guy. Then the image is the new figure. So after you've done something, you've like resized it or moved it, the new shape is the image. And then isometry, the last word, is a transformation that preserves the lengths of the sides. That means that the shapes are congruent instead of just being similar. So let's go through what all of that means. On the left-hand side, we see the three types of transformations that are isometries. So that would be a reflection, a rotation, and a translation. So putting that together with the definition of isometry, it says that the lengths of the sides are preserved. So therefore, with these three transformations, we end up with a congruent image. Both the pre-image and the image are the same shape and the same size. So let's look at those three examples more closely. A reflection is a flip. So it might be a reflection over like an axis. We've done those before. It might be a reflection over a specific line. We're mostly going to be focusing on reflections over like the x-axis or the y-axis though. So if you reflect something, it's the same shape and the same size. It's just flipped. Here would be the pre-image. That's the original figure. And then here would be the image. That's the new figure. And those two shapes have the same size and the same shape. They are congruent. Rotation is a turn instead of a flip. So the pre-image would be here, the image would be here, and we've rotated it, we've turned it instead of flipping it, but it's still the same size and the same shape. A translation is a slide. Here's the pre-image and here's the image. So we've taken an image and we've basically used our scissors tool to just slide it across the page. Again, same shape and same size. So the word that encompasses reflections, rotations, and translations is an isometry. An isometry is the definition saying that we've done some sort of transformation. We've changed the shape somehow, but it's congruent. It holds the exact same shape and size. So those are the three isometries. There's one transformation that's not an isometry, and that's the dilation. So dilations have a similar relationship. It's the same shape, but it's a different size. And the size is a proportional size. So in this one, it looks like the pre-image is the pink. And it looks like the image is the blue. The reason I know that is because I'm looking at how they've defined the letters. And if you look at the pre-image, it's A, B, and C. And if you look at the post-image, it says A with this little apostrophe, B with the apostrophe, C with the apostrophe. We call that prime, just the way that we pronounce it out loud. We would say A prime, B prime, and C prime. And that's just a way to communicate that that's the new figure after a transformation. So the pre-image has the original letters. That's the starting place, A, B, and C. And then you can see that A turned into A prime. It was a stretch. They stretched the pink figure. B turned into B prime, and C turned into C prime. The new triangle has a proportional relationship, but it's the exact same shape. The angles are all the same. The sides have proportional relationship, but they're not the exact same size. So 3 isometries: reflection, rotation, translation. One transformation that's not an isometry would be the dilation. And I'll highlight that in green just to show all of the things I've highlighted in green those are the 4 transformations. 3 of them are isometries, 1 of them is not an isometry. Today we're only going to be focusing on translations. The slide. So let's take a look. So I'm going to be showing some of the evens on this page and leaving some of the odds for you guys to do. So I'm just going to pick number 2 to start. So we are doing a translation here, and we need to do 1 unit left and 2 units up. One way you can do that, especially if they give you a nice graph like this, is just to literally do that to each of the points. So 1 unit left and 2 units up. 1 unit left, 2 up. 1 left, 2 up. Now I'm going to have the 3 new points of my new shape. So since that was point Y, I'm going to call this Y prime. That shows that I've done a transformation to it. G, I'm going to call the new point G prime. M, I'm going to call the new point M prime. And then here is my new triangle. Now, the green highlighting that I showed, you don't have to do that. I just did it to demonstrate it. What I'm demonstrating is that I've moved the original triangle 1 unit left and 2 units up. It's like taking the scissors tool and just sliding it down the page. Another way you can do this, especially if they don't give you a graph, is by looking at the points. So the original Y was, let's see, 1, 2, -3, 0. The original G is 0, -2. And the original M was -3, 1, 2, 3, 4, -4. So let's say they only give you the points and they don't have a graph for you. 1 unit left is basically like saying whatever the X value is, subtract 1 from it. That would be 1 unit left. 2 units up is like saying whatever the Y value is, add 2 to it. So to get Y prime, subtract 1 from the X value, -4, and add 2 to the Y value. So my new point should be at -4, 2, which is where it's at. For G prime, subtract 1 from X, so -1, add 2 to Y, 0. That is where it ended up. And M prime, subtract 1 from X, -4, add 2 to Y, that would be -2. So if they don't give you a graph, if you create a rule like that based on what the translation is, that's an easy way of doing it. Okay, so let's try one of the odds, and then I'm going to go over it for you guys. So I'd like you guys to try number 1, pause the video, come back to go over the answers. All right, hopefully you're ready to go over it now. What I'm going to do is trace this, and I'm just going to write B prime, T prime, and G prime, because I'm going to be moving all of this. And take my scissors tool. I need to go 5 units right. 1, 2, 3, 4, 5. And what I did was I just kind of kept my eye on T prime, and I moved T prime 5 units right. The other ones just followed. Now I need to move it all 1 unit up. So I'm looking at T prime. I want to get T prime 1 up. And there we go. So G prime is here, T prime is here, B prime is there. And I could have used other strategies as well. I just wanted to show you guys that. So that's how to do a page like this. They're all pretty much exactly the same. On a page like this, it's the opposite. So I'm going to look at number 8 here. So they've done the pre-image and the image for us. And I can tell that based on where the primes are labeled, the black shape is the pre-image and the blue shape is the image, the new one, because the blue has all those primes on there. Here they want me to describe the rule. They've already done the translation. They want me to write what the rule is. All you have to do is look at one point in particular. So I'm just going to choose T again. So T went from here to here. I can see that that is 1 up and 1 left. and that is good enough for your answer. This is your answer. You could write the words up and left. That's totally fine. If you want to be really fancy, you could say something like this. So 1 up, that's ends up being y plus 1. That's what 1 up means. 1 left would be x minus 1. So basically, if I take the original coordinates of t is 1, 2, 3, negative 1, and I go to t prime is 2, 0. I followed the rule that I just wrote. I did x minus 1, that gets me from 3 to 2, and I did y plus 1, which gets me to negative 1 to 0. So if you want to be fancy, you could write your answer like that, and that works as well. So either one of those is acceptable. Can you guys try the video, pause the video, and try number 7, please? Okay, so hopefully you are paused and completed. I'm going to focus on Z for this, but it doesn't matter what you focus on. So I see that it went 1 up, and 1, 2 over. So 1 up, 2 left. Oh, I did it totally backwards. Sorry. I started with the blue, but I was supposed to start with the black. So it's actually 1 down, 2 to the right. Sorry about that. And if you wanted the fancy answer, 1 down refers to y minus 1. 2 right refers to x plus 2. So like left and right, go with x. Up and down, go with y. Left and right, go with x. Up and down, go with y. So you could either say this for your answer, or you could say that for your answer. All right, and then this page, it's basically, well, some of these are saying tell whether it's a translation. So there's a couple questions like that on the page. So if it's a translation, remember that a translation is an isometry. So in order for it to be a translation, it needs to be same shape as if you took your scissors tool, and then same size. So you didn't resize it at all. If it's bigger or smaller, it automatically can't be an isometry, which means it's not a translation. And then the third rule, since we are looking at translations only here, because we're not looking at rotations or reflections right now, is that it has to be a slide. So it can't be a flip and it can't be a turn. So if it's asking you tell if it's a translation or not, these are basically like the 3 things you're checking. And then, so some of the questions on the page are about that. The other questions on the